and welcome to Quasar Does Astronomy. I'm Quasar, and if you recognize this camera angle, you know exactly who we're debunking today.
Who wants to use some kindergarten science to prove the stationary Earth again? It doesn't even involve a merry-go-round this time.
Ooh, I'll do it. I'm pretty sure I can do kindergarten math.
Let's say this is our globe, okay?
Okay, this is our globe.
These are 3 points, stationary points on this supposed rotating globe.
Okay, I'll just draw my 3 points. Not bad.
We'll call this the east coast of the United States, center of the United States, west coast of the United States, okay?
Okay, I will redraw my globe and 3 points. There we go. Better.
In order to represent that, going in a straight line, all you have to do is take a car, attach a tow line to a wagon, attach to another tow line to another wagon.
Okay, I will hook up my generic car. To a minecart. And a Red Ryder wagon. Not a very good artist.
Not to scale. Scale has nothing to do with anything other than the ratios of time that it would take for the drone to travel each direction.
Side note, this is a tangential velocity at the equator, not in North America where this thought problem is taking place.
So for this example, if this car is going 10 miles an hour and it's towing these 2 wagons, that means they're all going 10 miles per hour. You can think of this as the 1,000 mile per hour rotation of the Earth.
Well, I wish you would have told me that before I redrew the Earth.
So if I have a drone in the middle of the United States with a governor on it that allows it to go no faster than 1 mile per hour, I take the drone off and go at 1 mile per hour this way, following the car going 10 miles per hour. And then do the same. Take off here and do my 1 mile per hour. Travel this way. Which will the drone reach faster? This wagon or this car? Anyone with common sense knows it will reach this wagon first.
Okay, we finally get to do some math. So the motion of the car, the minecart, and the Red Ryder wagon are moving, in this example, to my right, your left, at 10 miles per hour. Now, we have 2 scenarios. Scenario 1, the drone will lift up here and will move in this direction towards the car. Now, we can view this from the frame of reference of the drone, moving at 1 mile per hour. Now, if the truck or car or whatever vehicle you're using for this demonstration is moving at 10 miles per hour in this direction and the drone is moving at 1 mile per hour in this direction, the net velocity will be the car moving at 9 miles per hour away from the drone. So the drone will never actually reach the vehicle. Now, the second scenario will be this drone lifting up and moving backwards toward the Red Ryder wagon. Now, if we land, or we should be able to land, in this case, in the Red Ryder wagon, because the cart is moving this way at 10 miles an hour, and we're moving backwards at 1 mile per hour. This gives us a net velocity of 11 miles per hour in this direction, in the frame of reference of the drone standing still. So that means that eventually this wagon right here will pass under us and we'll be able to land, assuming that we're a good drone pilot. Now, again, to kind of summarize that, the first scenario, we lift up, we move towards the car, but we never reach the car because it's traveling too fast. The second scenario, we lift up from the cart, we move backwards towards the second cart, the Red Ryder, and we can land in the Red Ryder because the Red Ryder will move forward and go under us at some point, and we'll be able to land there because we're traveling backwards at 1 mile per hour and it's moving forward at 10 miles per hour. So it's a net movement of 11 miles per hour to the right in our frame of reference.
With this being factually representable as 3 points on a fixed globe going at the same speed, with an independent drone going a slower speed each direction between them, that cannot match anywhere near the same times of air flight. Therefore, neither can planes on the supposed rotating Earth.
Well, actually, Daniel Pratt, what you did is you made the drone independent of the car and cart's system, and that means that it's no longer being given that 10 mile per hour velocity from the cart. So, in this case, in the scenario you provided, the cart will not be pulling that drone along at 10 miles an hour anymore, and the drone will have the opportunity to go at its 1 mile per hour, which means that, again, it will never reach the car, but it will reach the back wagon because the back wagon will basically accelerate underneath of it. Now, in order to do what you've suggested in this car-cart system, you would have to have the drone leave the atmosphere of the Earth so that the Earth is allowed to freely rotate underneath of it. Because otherwise, the drone is in the atmosphere of the Earth, which is also rotating.
Now, these globe priest propagandists will start kicking and screaming like the most rabid hyena monkeys you've ever seen in your life.
Looked it up, not a real creature.
Much like if you were doing this in a pool and going upstream and downstream.
It works out in basically the same way I described earlier. It's all about relative motion, motion of one object compared to another object.
Even though that's contradictory to everything physics shows us in this world, they will insist upon it.
Except I just did the math and explained how it wasn't.
What they will never, ever, ever do, because they can't, is prove it with actual scientific demonstration.
Prove what? I did the math. If you want to take the drone through the scenarios I described, then be my guest. Although I don't know how you're going to get a drone to leave the atmosphere.
They will come out and say how stupid I am because I do my science on a notebook with a Sharpie.
I mean, if you noticed, I did mine on a notepad with a pen. So I don't know what you want.
And then tell you how you should listen to Aristotle's with his stick in the desert because he was a brilliant scientist and stuff. But don't use any of today's technology to prove you're on a stationary Earth.
Eratosthenes was a Greek philosopher among many other things. He took a rod and a well, along with 2 locations a known distance apart, to calculate the circumference of the Earth. Using simple geometry, he was able to calculate the angles that the sun was casting a shadow on, and then use those angles, along with, again, basic geometry, to calculate the angle of the circle that those 2 distances represented. Now, he was then able to take that distance and the angle, knowing that a circle is 360 degrees, and calculate the approximate circumference of the Earth. The thing is here, you have much better tools and technology at your disposal than Eratosthenes ever could have imagined. He just used his better. Anyway, that will wrap up my video today. I hope everyone learned something, and sorry to run, but I've got a flight to catch. Enterprise, 1 to beam up. I'm Quasar. and this has been Quasar Does Astronomy. Keep learning.